All right, welcome to The Explainer. Today we are diving into a really mind-bending theory from a researcher named Kevin L. Brown. It's called Triune Harmonic Dynamics, and honestly, it might just change how you think about everything. It all starts with one massive question.
So, you've probably heard about the multiverse, right? The idea that there are countless universes and we just got lucky. We hit the cosmic jackpot and that's the only reason we're here. But what if it's not about luck at all? What if existence isn't a lottery, but more like a competition with a really, really tough rulebook? Okay, so here's how we're going to break this all down. First, we'll challenge that whole cosmic lottery thing. Then we'll get into the actual rules a universe has to play by. We'll look at the two different ways a reality can form, take a little tour of some other potential universes, and wrap up with the big one. How could we even test a theory like this? All right, section 1. Let's really get into this cosmic lottery idea. The popular view is, hey, we're a cosmic accident. But this theory flips that completely on its head. It says our universe isn't here by chance. It's here by necessity. It's almost like it had to exist. So on one hand, you've got the standard multiverse idea. It relies on something called the anthropic principle, which kind of says, we're here because we're here. A little circular, right? But on the other hand, you have structural selection. This idea doesn't ask why we're so lucky. Instead, it asks a much deeper question. What are the absolute non-negotiable rules that any universe, must follow just to hold itself together? Okay, so if a universe has to follow a rule book, what's in it? Well, according to this theory, there are 3 essential ingredients for any stable reality. Let's dive into them. This quote really gets to the heart of it. Reality isn't just anything goes. It's a filtered result. Think of it like a giant cosmic filter. Only the potential universes that are stable and coherent enough actually get to become real. The rest just don't make the cut. So the first rule is something called coherence. The best way to think about it is like the focus on a TV screen. If coherence is too low, all you get is static, pure noise. Nothing can form. But if coherence is cranked up way too high, the image is frozen. It's so rigid that nothing can change or evolve. So for a universe to work, it needs to be right in that sweet spot. A clear signal, but one that can actually change over time. All right, next up is curvature. And no, we're not talking about space-time, like with gravity. This is about informational curvature. It's about complexity. Let's go with a Lego analogy. Low curvature, that's like having only one type of simple flat brick. You can't build much. Super high curvature, that's a pile of Legos so complex and dense it just collapses in on itself. You need just the right variety and density to build cool, complex stuff. You know, like us. And the last ingredient, maybe the most important, is triadic balance. This is basically the engine of reality. For anything interesting to happen, you need 3 things working together. You need formation, a way to create stuff. You need interaction, a way for that stuff to, well, interact. And you need integration, which is basically a memory, a way for the past to affect the future. Take away any one of those, and you get a universe that's totally dead, totally chaotic, or just frozen. So let's put it all together. You've got these 3 core variables: coherence, curvature, and triadic balance. These aren't just abstract ideas. You can think of them like the main settings on the control panel for reality itself. Tweak these dials and you determine whether a universe can even exist, and if it does, what it's going to be like. Okay, so given those rules, how does a universe actually come to be? Well, the theory proposes 2 distinct paths to reality. Path number 1 is for a completely independent, standalone universe. For one of these to pop into existence and stay there, it has to pass all 3 of those big tests we just talked about. It needs enough coherence to hold together, the right amount of curvature to have structure without collapsing, and it absolutely needs that 3-part engine: formation, interaction, and integration to be running. Now, this second path is really cool because it's not about making brand new universes. It's about building new layers of reality inside a universe that already exists, like ours. Think about it. The same basic rules apply at the tiniest quantum scale, then again at the biological scale with life, and even again at the cognitive scale with things like human society. It's like reality is building on itself, using the same blueprint over and over. All right, now for the really fun part. Let's imagine we could get our hands on that cosmic control panel and start turning the dials for coherence and curvature. What kind of other universes could we create? Let's take a tour. First stop, a slow glass universe. For this one, we crank the coherence dial way, way up. Everything is super stable, super connected, and change happens at a snail's pace. I mean, a glacial pace.
So what would it be like to live there? Well, for one thing, time would feel like it's stretching on forever. Your sense of you would be incredibly solid and unchanging. Just having a single thought could take what feels like an eternity to us. It's a universe that's ultra-stable but almost completely frozen. Okay, now let's flip the script completely. Let's imagine a hyper-reactive universe. Here, we've turned the coherence dial all the way down. Information just zips across the entire cosmos in an instant.
Living here, the whole concept of being an individual, a me, might not even exist. The line between you and the rest of the universe would be completely blurred. It'd be less like being a person and more like being a single ripple in a giant cosmic ocean of awareness, connected to everything all at once.
Last stop on our tour. What happens if we mess with the curvature dial and turn it way up? We get a nested universe. This place would be just weird. Space wouldn't be linear. It would be all folded and layered, like cosmic origami. Trying to get from A to B here wouldn't be about distance. It'd be more like jumping between different rooms that are all connected in strange ways. You could be here one moment and then pop into a totally different pocket of reality the next. It'd be like trying to navigate through a dream.
Okay, exploring these wild universes is a blast. But for this to be real science, it has to be testable. You have to be able to prove it wrong. So how in the world could we actually test a theory about the very structure of reality?
Well, it all comes down to this one central prediction. The hypothesis is that any stable, complex system, and I mean anything from an atom to a galaxy to a living cell, has to have that triadic support. It needs those three phases: formation, interaction, and integration. No exceptions.
And that's the key right there. That's how you can try to break it. The theory makes these really specific, falsifiable claims. If a scientist anywhere ever finds a stable system that gets by without one of those three phases, boom, the theory is wrong. If we find evidence of memory without any physical structure to hold it, the model fails. That's what makes it powerful science. It tells you exactly how to prove it's incorrect.
So when you step back and look at the whole picture, what this idea from Kevin L. Brown really gives us is a completely different way of seeing our place in the cosmos. Maybe, just maybe, we're not a cosmic accident. Maybe our universe, and even our own consciousness, isn't some 1 in a trillion lottery ticket. Maybe we are a direct, logical result of the fundamental rules of information itself. Our existence isn't a bug, it's a feature. And that is something to think about.